Hey guys. All right, this is Miss Ross. Hope y'all are having a beautiful, beautiful day and that Santa Claus was good to you. All right, so what we're going to be working on today is Fan 5, Week 13. And if I open this up, you'll see that it says here that problems number 1 through 3 need bar diagrams every time. So as we're doing this together today, make sure you draw the bar diagrams. All right, so Henry was making some brownies for school and brownies and cupcakes for his school fundraiser. Nice guy, right? Okay, so if the brownies needed 4 2/2600 cups of sugar and the cupcakes needed 5 1/10 cups, how much sugar would he need altogether? So I want you to draw a bar for the top and put a question mark inside of it because you don't know how much sugar he has altogether. You don't know that right now. But you do know some parts for the brownies and parts for the cupcakes. So let's draw one part for the brownies. There is 4 2/2600 cups of sugar for the brownies. And then for the cupcakes, he needs another 5 1/10. Okay? So what I'm going to do now is I'm going to look at my problem solving flow chart. And most of you have this because we've been using it throughout the year. So, do I know the total? No, I don't. See, I don't know the total. So, no, I don't know the total. Are the parts that I have equal? Well, no, this one is 4 2/2600. This is 5 1/10. So, do I have equal parts? No, I don't. So, I have to add. It even gives a little example of what your bar model is going to look like. You're going to have a question mark on the top, and then you'll have unequal parts. All right, so here we go. What we need to do is we need to add. So let's do this right here in this blank. We've got 4 2/2600 added to, let me zoom in on this, 5 1/10. Okay, and since you have, see, we lined up the decimals. We lined up the ones placed together. So the 4 and the 5 are lined up together. We have the decimals lined up together. And then we've got the tenths place are lined up. And then, Ms. Ross, what do we do here about this whole? What I like to do is I'll just like to add a 0 in that whole so that I don't get confused. Then when I add them together, I add up the hundredths first. 6 plus 0 is 6. 2 plus 1 is 3, and 4 plus 5 is 9, and 3600 cups of sugar. And there is my answer. And y'all know Miss Ross likes to highlight an answer. It makes me feel fuzzy inside. There we go. There is my answer. All right, next one. The drama club members need to buy 869 bags of popcorn to serve during the intermission of their play. Well, that sounds like a total, doesn't it? That's the total number of bags. If the popcorn comes in cases of 24 bags, how many cases do they need? Okay, so you know how many total bags they need. So draw this up here. They need 869 bags total, okay? And these are divided into cases of 24 bags. So if I buy a case, that gives me 24 bags. If I buy another case, that gives me another 24. If I buy another case, that gives me another 24, all the way down until they're all used up. Okay? So now let's look at our handy dandy flow chart. All right, here we go. Zooming out again. My handy dandy flow chart. It says, do I know the total? Yes, Miss Ross, I do. The total is 869 bags. Okay, so yes. Do I have equal parts? Well, 24, 24, 24, those are equal. So do I have equal parts? Yes, I do. So then I know I need to divide. And it even gives you a picture of what your bar model is going to look like. The total is going to be on top, and it's going to be divided into equal parts. So here we go. We have to take 869, and we have to divide it into 24s, okay? So come on a different sheet of paper. Don't be scared. So write 869, and you're going to divide it by 24. Now, the biggest piece of advice I can give you when you are dividing large numbers like this is to make a list of multiples out to the side. So go 24, 24 plus 24 is 48, plus another 24 is, let's see, 72, plus another 24 is 96. And I think that should probably do it for right now. Okay, so let's just keep it right there. See what we can do with this. All right, so how many 24s are there in 8? There are none. Put an X above it. How many 24s are there in 86? Well, there are 1, 2, 3, because 96 is too many. Put 3 right here. 3 times 24 is 72, and you've already got it right here. When you subtract, you get, let's see, 6 minus 2 is 4, 8 minus 7 is 1, all right? Then you have to bring down the 9. All right, so now you're asking yourself, how many 24s are in 149? All right, so I'm thinking to myself, do I know, let's see, how can I easily solve this? Well, let's just try some numbers here, okay? So let's take 96 here and let's divide 24 to it. Add 24 to it to get another multiple. So that is 0, carry the 1, 10, 12. All right, so the next factor is 120, plus another 24 is 144, plus another 24 is 168. Okay, so here's our number right here, 144. So that is 1, 2, 3, 4, 5, 6 24s. So how many 24s are in 149? There are 1, 2, 3, 4, 5, 6. There are 6. 6 times 24 is 144 with 4 left over. Okay, now here is the problem. The issue is that we can't just not give out 4 bags of this popcorn, okay? Because it's coming in cases of 24. I don't like this question. Hold on, guys. I'm going to pause this for. Okay, I'm back. I needed a second to gather my thoughts on this. Okay, so we've divided it correctly, and there is a remainder of 4 bags left over. So what that means is that you've got 36 bags that have 24 bags, you have 36 cases that have 24 bags in them. So 24, 24, 24, 24. If you went all the way down, you would have 36 cases that have 24 bags in it. But then you would have these 1, 2, 3, 4 bags that you still need, because you have to have 864 bags. You've got to have these 4 more. If you don't have these 4 more bags of popcorn, then not all the people at the play are going to get popcorn. So you have to buy another case. Okay, so that means that you've got 36 cases, and then you need plus 1 more. Miss Rouse, why do I have to buy a whole nother case if I only need these 4 little bags? Because they're not going to let you split up the case. So that's going to be 37 total. Okay, I hope that made sense after I finally got myself together there. Okay, all right, next one. A team is playing 23 games. In each of 12 games, 134 tickets were sold. In 11 of the games, 375 tickets were sold. What was the total number of tickets sold? Okay, so what you got to do, I'm going to make you 2 bar models, okay? What you need to understand is that there is a total of 23 games, okay? And that there were 12 games that scored this many points, and then 11 games that scored this many points. Okay, so I hope that makes sense, that you've got these 11 games and these 12 games added together to make 23. Okay, so we're going to make a big bar model with that information. Okay, so we don't know how many total points were scored. Okay, but we do know that in the first 12 games, there were 134 tickets sold in every game. So that's 12 times 134. 134, 134, 134, 134. All right, then we also know that in the next 11 games, each of the games scored 375. So you've got 375 11 times. 375, 375, 375, 375, going all the way up until you get until you get 11 games. So what you have to do is you have to multiply 12 times 134, then 11 times 375, and then you add those two pieces together to get the total for all 23 of the games. I hope that makes sense, because there's 12 games that scored this many points, 11 games that scored this many points. Multiply, and add together to get the total in all. So here we go. We got some math to do. I'm going to come over here. Let's do 12 times 134 first. So you've got 134 times 12. So 2 times 4 is 8. 2 times 3 is 6. 2 times 1 is 2. Then what you're going to do is you're going to cross this out and put your 0 there, because now you're going to multiply by the tens place. 1 times 4 is 4. 1 times 3 is 3. 1 times 1 is 1, and then you can add and you get 8, 10, carry the 1, 6, and 1, 1,608. And that's how much was scored in the first 12 games. So I'm going to write that right under here, 1,608. Then I'm going to do the second multiplication. So I've got 375 multiplied by 11. Here I go. 1 times 5 is 5. 1 times 7 is 7. 1 times 3 is 3. Then I can cross this out, put a 0, because now I'm multiplying by the tens place. 1 times 5 is 5. 1 times 7 is 7. 1 times 3 is 3. Add them together, and I'm going to get 5. This is 12, 10, 11. Leave the 1, carry the 1, and this is 4. So in the last 11 games, there was 4,125 points, tickets sold. Okay. So now to get the total of all 23 games added together, you have to add these two numbers. So I've got 1,608 added to 4,125. Let's go. 8 plus 5 is 13. Leave the 3, carry the 1. 1 plus 2 is 3. 6 plus 1 is 7. 1 plus 4 is 5. So your answer should be, if I have done my math correctly, your answer should be 5,733 total. So that means that I can put my answer right here, 5,733. And you guys know that Miss Ross loves to highlight an answer. All right. All right. Next one. Miss Schaefer is conducting a survey to find out the favorite types of music in the 5th grade. After the children vote, how should Miss Schaefer organize her data? Okay. So the first thing I always tell the students in my classroom is to just answer the question. Okay. So Shamori, what's your favorite type of music? Shamori says, Miss Rose, I like R&B. Okay, so there's one. So let's ask Tristan. Tristan, what's your favorite type of music? Tristan says, I like country. Okay, so I'm going to write that down. I'm going to try one more. Avery, what's your favorite type of music? Miss Rose, I like jazz. Okay, so we write down jazz. All right, and then look at them. What are the answers? Are they numbers or are they names? This is a name of a type of music. This is a name of a type of music. This is a name of a type of music. So these are names, which means that this is categories. This is categorical data. Write that down. Okay? And categorical data is going to be organized in a bar graph. So this is going to be a bar graph. So how it's going to look is like this. You're going to have, so you might have R&B, you might have country, you might have jazz, and then they're going to have bars that show how many kids liked that type of music. But across the bottom, you're going to have names, and names is categories. This is categorical data, okay? So it is going to be organized in a bar graph with the names across the bottom. All right, number 5. Woo, we finally got there. This is a hard Fan 5 today. All right, number 5 says, which statement is true? All right, so this is asking about quadrilaterals. It's asking about parallelograms, rhombuses, rectangles, squares. So let's come back. We have written this anchor chart a gamillion times, but we're going to look at it again. Remember, this is the quadrilateral family, and everybody in the quadrilateral family has 4 sides, okay? Every member of the family has 4 sides. Parallelogram has 4 sides, trapezoid has 4 sides, rhombus, rectangle, and the square. All of them have 4 sides. That's what makes them part of the quadrilateral family. Okay, so then remember that the first 2 members in the quadrilateral family are Uncle Graham and Uncle Trapeze. Graham and Trapeze, they are brothers, okay? And they both have 4 sides. That's what makes them part of the quadrilateral family. But Trapeze only has 1 pair of parallel sides. Uncle Trapeze, he's got 1 pair. He's only got the top and the bottom, or, you know, he could have the 2 sides as well, but he's only got 1 set of them. So sometimes Uncle Trapeze can look like this, and sometimes he can look like this. But his defining characteristic is that he only has 1 pair of parallel sides, okay? Now, Uncle Trapeze, he never gets married. He never has any children. So it's just him in the family that has 1 pair of parallel sides. Everybody else in the family has 2 pairs of parallel sides. Okay, so then let's move over here to Graham. This is Graham. Graham has 2 pair of parallel sides, okay? And his opposite sides are equal. And he has twin boys. And in the grand tradition of people that have twins, he gave them both an R name. He named them rhombus and rectangle. And they both have 4 sides, just like him, except for that rhombus's sides are all equal, and rectangle, his angles are all equal. He has 4 right angles. Okay, so rhombus has 4 equal sides, and rectangle has 4 equal angles. Well, these 2 decide that they want to buy a dog, okay? They want to buy a dog. And rhombus wants the dog to be just like him. It wants to have 4 equal sides. And rectangle wants it to be just like him. He wants it to have 4 right angles. But they can't agree on it. So in the end, they decide to compromise. And what they decide on is that they decide that their dog is going to have 4 right angles and 4 equal sides. He's going to get something from both of them. And they decide to name their dog, and put a little tail on them. They decide to name their dog, little ears here. This is going to be an ear. That's a puppy dog ear, in case you didn't know. Here, let me give him another ear over here. Let me give him an ear right here. That's a puppy dog ear. They decided to name their they decided to name their dog a square, okay? So, but the main thing that you need to understand about the quadrilateral family is that each shape is always the things that are above it, okay? So a square is always a rectangle. A square is always a rhombus. A square is always a parallelogram. A square is always a quadrilateral, okay? So if you look at my arrows here, it is always the things that are above it. Sometimes it's the things are below it. But if it doesn't have any lines connecting it, it is never that thing. So a square is never a trapezoid. A rectangle is never a trapezoid because there are no lines connecting it. okay? So it's always the things above it, sometimes the things below it, and never the things that aren't connected to it. So let's come back over here and let's look at our questions. It says, are all parallelograms squares? Well, the only thing that a parallelogram always is a quadrilateral. So that's not it. Are all parallelograms rhombuses? Well, the only thing a parallelogram always is a quadrilateral. So that's not it. Are all rectangles squares? Well, rectangles are always parallelograms. Rectangles are always quadrilaterals. But rectangles are not always squares. They're only sometimes squares. So that's not it. And then here, are all squares rhombuses? Square is always going to be the things above it. So a square is always a rhombus because a square is always going to have 4 equal sides and a rhombus is always going to have 4 equal sides. So that is our pick. And children, I believe that that might be the longest Fan 5 we have ever done. Hopefully tomorrow we can shave some time off. All right. Love y'all. Be sweeties. Bye.